Hello, I am Mannix Fernandez. I will be talking about the basic principles of model building in chemistry. My esteemed colleague, Adam Iverson, is missing, but I assure you he did help me on this, and you'll see a sick animation from him later. Now, the basic principles of model building in chemistry is you have your molecules. These are the molecules. Well, this is just a molecule. For those who don't know what a molecule is, it's a very basic building block made of atoms. 3 of them. Now, back to this molecule. This is water. Here we have an oxygen atom and then 2 hydrogen. The chemical equation of water, H2O, tells you the description of the molecule. The subscript represents the number of atoms of that element in the molecule. H subscript 2 represents 2 hydrogen. Now, when a reaction occurs, you can often just see what happens with your own 2 eyes, but you can't get the full picture unless we model. Take this example between baking soda and vinegar. When vinegar interacts with baking soda, a chemical reaction occurs that causes the baking soda to fizz up and spread all over the place. But first, allow me to get the proper safety equipment. So, now that we're all prepared with our proper safety equipment, let's watch this chemical reaction. Yes, so now the reactants. The reactants are on the left side of an arrow. The arrow represents a chemical reaction. The reactants, of course, are baking soda and vinegar. Baking soda is used in cooking and toothpaste. It is comprised of sodium, hydrogen, carbon, and 3 oxygen. A plus sign shows that there are more than one reactant and that they work together to make the products. The other reactant is vinegar, a sour liquid made of carbon, 4 hydrogen, and 2 oxygen. These molecules combine, creating CO2, H2O, and another molecule that we'll get to later. The combination of baking soda and vinegar looks a little bit like this on the molecular level. The model we have on paper is a little less interesting than the beautiful animation provided by Adam. But in chemistry, models are extremely important to show the little stuff that we don't see with our eyes, as I've mentioned before. Now, as well mentioned before, the arrow represents the chemical reaction. Now, here on the product side is the, new products. But they're not new, they're just recycled. Because the cursed rules of the universe prevent us from making new stuff. As someone more intelligent than me has put it, so, all of the matter that we have since the Big Bang is what we're stuck with. It's been recycled billions and billions of trillions of times over. Now, for this chemical equation, we have to keep it absolutely 100% balanced. And you can tell it's balanced. I counted, so you don't have to. And now, the products. And so, after this culmination of 2 different molecules combining to create 3 new molecules with the same number of atoms, so it doesn't upset the pesky laws of the universe, we have our 3 products: CO2, H2O, and CH3COO. Whatever that is. I don't know, I didn't Google it. Right, so, you'll notice these little things that I've been avoiding. These things represent the state of matter that the thing is in. Well, the molecule is in. There's gas, solid, liquid, and aqueous. We don't talk about plasma. Now, aqueous just means that it's dissolved in water. And so CH3COO is aqueous, represented by AQ, which means it's dissolved in the water that we also produce, which is a liquid. CO2 is a gas. And on the other side, if we just rewind for a second, we can see that baking soda is a solid and vinegar is a liquid. Now, with all that, we have our completed model, the reactants on the far left, the products on the right, an arrow in between representing chemical change, and we've even described subscript and the definition or description of what state of matter these molecules are in. That was the basic principles of model building, with the example of baking soda and vinegar.